Hey, this is Rustology. Do you know the difference between a strong acid and a weak acid? Let's look at the ion flashcards and the ionic bond disk model. It'll make it so easy to understand. Let's start. The Arrhenius definition of an acid was something that gave off hydrogen. Well, hydrogen tends to lose one electron and become H+. So an Arrhenius definition would be that it gave off this hydrogen ion. Now, when that's in water, it will combine together with the water and become something called hydronium ion. So you have water, H2O, and an extra hydrogen, so it's got a charge of +1, H+. Now, those things, whether it's hydrogen ion or hydronium ion, can combine together with other ions. So if we look at this one here, this is hydrogen chloride, and this is also, when it's in water, called hydrochloric acid. In a similar way, we have hydrogen nitrate. In water, it's called nitric acid. And lastly, we have what's called sulfuric acid. Now you notice it's got two H's here. But now let's look at what actually happens here. Okay? So with the hydrochloric acid and the nitric acid and the sulfuric acid, these are all, three of them are strong acids. And what makes it a strong acid is that this hydrogen comes off so easily. Oops, I can't do it with one hand. Here, there it goes. Okay, so they stick on so tightly. Huh? So when these come apart in water, they don't go back together. That's one of the definitions of a strong acid. They just come apart completely. And now the same thing happens with nitric acid. Let me pull that one off. So here we have nitric acid, and it comes apart completely. So you're going to end up with a hydrogen ion in certain concentrations and a nitrate ion. The same thing, chloride ion and hydrogen ion. Now, for the sulfuric acid, it's a little different. One of the hydrogens will come off really, really easily. Okay? That's the strong part of the acid. So you'd have one hydrogen coming off very fast, and the second one doesn't. It tends to stay in this form. Now the term that's used for how much it comes off or not is the acid dissociation constant. Well, hydrogen sulfate or bisulfate is considered to be a weak acid. It has a low hydrogen dissociation constant. Sulfuric acid, this first hydrogen comes off very, very fast, so that's a strong acid. So whether it's hydrochloric acid or nitric acid or this first hydrogen for sulfuric acid, that would be a strong acid. This one barely comes off. It does come off, and it goes back and forth. So it'll come off, it'll go back on, it'll come off, and it'll go back on, but it tends to stay in this form more than in coming apart form. Now, a weak acid is this one here. This is phosphoric acid. Phosphate tends to have a charge of -3, okay? And it'll pick up 3 hydrogens. 1, 2, 3. This is a weak acid. The first one of these will come off, and it has an acid dissociation constant. So you'd have dihydrogen phosphate then. Oops, we get rid of this one here. We'd have dihydrogen phosphate and an extra hydrogen. Now this next acid, this next hydrogen can come off, but it's even weaker, much weaker. So now we have hydrogen phosphate, and it's extremely weak acid. Okay? So you can see from the ion flashcards and the ionic bond disk model, chloride tends to pick up 1 electron. Here it is, picks up 1 electron, and I had that represented with a minus charge. And that can then hook onto a hydrogen to form the strong acid hydrochloric acid. In a similar way, nitrate, which is nitrogen and 3 oxygens bound together covalently, has an overall charge of -1. We see that represented here. That can combine together with a hydrogen, and it's a strong acid. It'll come off very, very fast. Okay? So sulfate tends to pick up 2 electrons here to be it's stable. It's a sulfur with 4 oxygens and has overall charge of 2-, which we see here, -1 and -2, and each of these will pick up a hydrogen. Now that first hydrogen is going to come off really easily, and the second one, which would be a strong acid for sulfuric acid, and the second one won't. for bisulfate. Okay, so that would be hydrogen sulfate. Okay, it doesn't come off very well. Now, again, in a similar way, we have phosphate. And phosphate is a phosphorus with 4 oxygens and has an overall charge of 3 minus. That's what it needs to be stable. And each of these minuses will pick up a hydrogen, but overall, phosphoric acid, when it's in water, is very weak. And the first one, the Ka1, or the acid dissociation constant 1, is the strongest, and then number 2 and number 3 are weaker and weaker still. Okay? So by using the ion flashcards and looking at what the underlying ion is that the hydrogens are sticking onto and how fast those come apart, you can then figure out, is it a strong acid or is it a weak acid? And then you can then go and do the calculations to figure out exactly what the acid dissociation constant is. Ask your teacher how to do that. It's not hard at all. Okay? That's how it works. Okay? An acid, by the Arrhenius definition, is something that gives off a hydrogen ion. There are other definitions, but that's the most straightforward, simplest one of them all. All right? Using the ion flashcards, which you can get from scienceglen.com or from Amazon, what my name is, okay? And using the ionic bond disk model, which is also available from scienceglen.com, and I'll put the link there, all right? Okay, thanks so much. This is fun. Thanks a lot. Bye-bye.